everyone to part 15 of our Smart Enemy AI series. And in this part, I'm going to be adding a long-range attack for our melee enemy. And it's going to look something like this. So if I'm standing far away, the enemy will jump, boom, and land attacking on me. I can show you in slow motion, far away, jump, and boom, land on the player. And if I'm close to the enemy, he's going to do a normal attack. And if I'm further away, he's going to do something pretty interesting. He doesn't just do a normal jump to my location, but he predicts where I'm going to be. So if I'm moving towards him, he's going to use my velocity, predict where I'm going to be. So you see now he's moving backwards because he knows I'm going to be behind him at a certain point, and lands where I'm going to be. So this is really useful because if I'm just running away from the enemy, it's very hard for him to hit me if he doesn't calculate first where I'm going to go. And we're also going to be doing a lot of things in this tutorial. We're going to be covering how to blend animations. So this jump is actually a blend of the normal jump animation with an attack animation. So I'm going to show you how to do that. And once the enemy lands, he no longer uses the blend. He uses the regular land animation from this montage. So it's going to cover a lot of really cool things, so let's get started. Alright, so the first thing that I want to show you is the animation that we'll be using. So this is the animation I got from Mixamo called Sword Jump. Well, I call it Sword Jump Attack. I'll leave the actual name in the description. And of course, as with all the animations from Mixamo, I added a root bone so we can have root motion. And what that means is you see this animation has movement in it. It means that the mesh is actually moving. Now, if I say enable root motion, then the mesh will also move with the capsule because the capsule is the actual pawn, is the actual actor. The mesh is just for display. So right now, if I do enable root motion, then you'll see that the mesh itself is no longer moving in this space, but the capsule will be. So the actual actor will move depending on the data in the animation. But we don't want to enable root motion for this attack because if we enable root motion, then this jump distance is decided by the animation itself. I don't want the animation to determine the jump distance. I want to calculate that in the blueprint because it's going to be based on where the target is. It might be a smaller jump, a larger jump, and so on. So I'm not going to enable root motion. But if I don't enable root motion and leave everything as is, the problem is that the mesh will still move. So the mesh will move, but the capsule won't. That means at the end of the animation, you'll see the mesh just teleports back to place where the capsule, the actual actor, is. So to prevent that, you can go here and say force root lock. So this doesn't enable root motion and prevents the mesh from moving as well. And this is what we want. If you don't have a root motion animation, then you don't need to do any of this because nothing moves anyway. Alright, so now that I've explained the animation, let me create the montage, the actual attack montage from it. So going here to our animation, right click, create anim montage. And I'm going to call it montage sword jump attack, something like that. All right, so I'm going to open it up. Now, first thing, you'll see that this animation has like a hop and then a jump. I don't want this hop. So I'm going to start the animation somewhere around here. So like 0.45 seconds. So you can do that by clicking on the animation and the timeline, go into the details and say start time 0.45. Great, now the animation starts at the jump itself. Great, so we need two anim notifies here. One to tell us in the blueprint when to jump, and one to tell us when to do the attack itself, the sword swing. So I'm gonna jump right about here when the feet leave the ground. So right click on the notify track, add notify, montage notify. Click on it, and we're gonna call this one jump. We don't have an implementation for the jump notify yet, but we're going to do that. And then right about here, maybe? Yeah, somewhere around here, we want the add notify again, montage notify, and call this one slash. Now slash, this is the same notify we're using for the regular attack, so we won't have to implement this, it's already there. All right, and that's basically our notify, our montage. So now let's implement this montage. So I'm going to go to my BP enemy melee. All right, and now we have only one attack, right? We have one sword slash attack that plays this montage, and that also has a slash notify. And on slash, it does this sphere trace and so on. So I want another attack that also does the slash, but does a jump as well. So we're going to create another one. Let me just move things a bit over here to give ourselves some space. All right, so we're going to have a sort of default attack. And we're going to have a short range attack. And we're going to have a long range attack. And also, everything here in this slash, I want it to be its own function or custom event, doesn't matter, because we're going to reuse it. So I'm going to just copy all of this. I'm going to move it somewhere here, and I'm going to make a new custom event and call it, I don't know, sphere damage or sphere trace damage. Does it take anything? Nope. I think that's all we need for it. All right, so I'm going to just comment this and put it in something called attack helpers, because the jump is also going to be an attack helper, right? So we have the sphere trace damage. We should also create a custom event. Actually, I'm not going to do this now. Let's do this a bit later. Let's first call our sphere trace damage here. All right. Now this is our short range attack, right? So I'm going to actually unplug this. Oh, and this also, the short range attack should also take input the attack target, which is an actor. And the same for the long range input attack target, which is an actor. All right, so I'm going to make the short range attack here instead of this default attack. And the default attack, what I'm going to do is just have it call short range attack. All right, and now we want to implement the long range attack. Now it's going to be very similar to this, but I don't want to reuse it. It's fine in some cases to copy and paste your code because we might want to change just the long range attack in the future and not the short range attack. So it's better not to have them tightly coupled. So I'm going to copy all of this and paste it here. And don't forget the attack target. All right. Now the differences are, this one plays a different montage. We want our montage sword jump attack here. You could just drag it. And we also want an additional notify switch called jump. And this is where we'll actually do the jump. All right, so right now we don't have anything calling short range attack and long range attack. In our behavior tree, if you recall, we have this task melee attack, and all it does is calls the default attack from the enemy AI interface. So I'm just, for testing now, we're gonna revisit this later, but for testing now, I'm going to make the default attack the long range attack so that we can test it out. All right, so now if I play, I expect this montage to be playing, but nothing will happen on jump. So let's watch. Enemy here, and yeah, they're jumping and attacking. So the attack is actually happening. I'm getting damaged, but he's not actually jumping towards me. He's jumping in place. So let me show you again. Yeah, he's just jumping in place, of course. Let me remove the cooldown, by the way, from the behavior tree, just to make our testing easier. All right. Now, one thing that's really important to note is that I'm going to play in slow motion here. Watch this. See, the health bar is in the center of the mesh. Why is that? That is because the capsule itself is not jumping. Let me show you. So if we go to the capsule component on the melee enemy, search for hidden. It's of course hidden by default. We're going to uncheck that so you see the capsule in-game. And if I play, watch the capsule as the enemy jumps. The enemy's jumping, but the capsule, the red capsule, is not moving. That means that the jump itself is only on the mesh. It's not on the capsule. And we don't want the mesh as well as the capsule to be jumping because we're going to calculate a jump here. So that means the capsule will jump and the mesh will jump even higher. So we don't want the mesh to move at all in the z-axis. And the reason the mesh is moving at all is because the animation itself has the feet or starting from the lower body is jumping upwards in the z-axis, and this has nothing to do with root motion. It's just the mesh is moving upwards. So to prevent that, we're actually going to only play the upper part of the animation. So I'm going to show you how to blend the upper part and the lower part with a different animation. So to do that, we're going to go to our ABP Mani. This is where our animation blueprint is. And we're going to add another slot here. So we have the default slot. This is where all of our montages play. I'm going to create another one, and we're going to select here the upper body. So to do a blend, blend the upper body and the lower body, we need to first do one thing. We need this main state here to be cached, which you can look at it as storing it in a variable. So I'm going to pull off it and say, I just search for cache and choose new save cache pose. And I'm going to call it the main states. So now that I have this as a variable, I can just use it like this, and I can use it multiple times. That's the main reason for caching it. So now I want to do one thing. I'm going to search for layered blend per bone. This is the node we want. This allows you to take in a base pose and a sort of secondary pose, and it blends them. So the base pose here is going to be our main state, and the blend pose is going to be our upper body slot, but it also has to have a source, and the source is going to be our main state again. So I'm going to copy this here. Now, the layer blend per bone, the way it works is that you have here, if you click on it, oh, don't forget to connect this. If you click on it, I have here this layer setup, which is an array. If I click it, it's going to give me two things, a bone name and a depth. So it's asking me at what bone in this mesh do you want to start blending. So I'm going to say spine underscore 1. So if you go here to the mesh itself, you'll see spine 1 is the lowest spine. So everything below spine 1, play the regular animation, which is jump, run, whatever you're currently doing. And in the everything above spine 1, play the montage that I'm giving you. And bone depth, I'm going to set to 1, blend depth. Blend depth, I don't really fully understand what it does. If someone knows exactly what blend depth does, please tell me. I have an idea, but it's not a very accurate one, I have to say. All right, so this is pretty much what we need for now. Let me show you what this looks like. So now, one more important thing is you have to go to the montage itself and tell it over here to play in the upper body slot. So I'm going to go here, slot name, upper body. This is going to happen. That's fine. If you just go away and come back, it's going to be working again. Okay, now if I play, Oh, and by the way, I have the tab key configured whenever I press tab to do slow motion. So now, as the attack happens, the actor is no longer jumping. You'll see he's just doing the animation, and he's not jumping. Let me show you again. Attack me, and he's just doing the attack. And only in the upper body. The lower body is staying the same. Great. So now if we actually do a jump, then he'll start blending the legs from the jump animation with the upper body from the montage. So to do a jump, I'm just going to do a dummy jump for now, do a launch character, and say launch him 500 in the z-axis. So he'll just jump vertically upwards. So let's see what this looks like. And yep, there we go. And you see the capsule, the entire capsule is moving this time, and the legs are being blended in with the upper body. One more thing also for the animation blueprint is in the layer blend per bone, I like to enable mesh space rotation blend. I find that this uses the mesh space to calculate the rotation instead of local space, and I find that it gives a better result. So let me show you again, and jump, yes, much better. All capsule is moving, and the legs are blended with the jump animation. Now, one more thing that you'll notice is that as the enemy lands, look what happens when he lands. You'll see that he's still blending with the jump land animation. So the jump has this jump and then jump land, where he does this with his hands. And he's blending in with the jump land, and it looks a bit weird. Because the animation itself has a really cool landing pose. Let me show you. So this is what the animation looks like when you land. So why isn't, because we're not blending the legs of the animation, we're playing the jump land legs. And I don't want that. I want, if the enemy is not moving, if they don't have a velocity, then play the full animation. Because if you don't have velocity, then there's no point in blending the legs, because if your velocity is 0, your legs aren't doing anything. So to do that, go back to the animation blueprint. And here we're going to do like an if condition in animation blueprints. There's something called a blend poses by bool. So if true, use this. If false, use that. So in our condition here is if our velocity, and we have a variable for velocity, I think here. Yeah, we have velocity. If velocity is not equal to 0, this is our condition. So that means if the character is moving, then blend normally, do everything that we just did here. But on the false, if the character is not moving, neither moving forwards, backwards, up or down or anything, then take the upper body slot just as it is and use it. Well, sorry, move this backwards a bit. Take the upper body slot and use it without blending it in anything. So we ignore the blend, we just use the upper body slot. So this means it will play the full animation, not just the upper part of the animation. So let's see how this looks like. Right now, I'm going to do slow motion again, jump, and as he lands, his velocity becomes 0. And nice, he plays the animation legs, the montage legs itself. Perfect. You want to see it again, not in slow motion. Here we go. Jump, boom, land. Great. Very nice. This is something we also want to fix, but I'll show you that fix for it later. Or if you didn't notice it, I'll explain what it is later. All right. So now we have our montage playing. We have a fake jump here. Now we actually want to calculate a jump to the player. All right, so we're going to create over here in our, next to the sphere trace in our attack helpers, another custom event, and we're going to call it jump to attack target. And it takes as input, oh, let's also, the capsule, let's hide it again. It takes as input our attack target. And if you recall, we already have a jump that we implemented in the navlinks tutorial. Jump to destination. Oh, it's not, sorry, it's not in the melee enemy, it's in the base enemy. Jump to destination. So in this jump, we used the suggest projectile velocity custom arc node to calculate the launch velocity that we need. So we're going to reuse this node as well. We're not going to reuse the entire function, but we're going to reuse the node because the function is going to be doing a few different things. So I'm just going to copy it here, go back to my melee enemy, and here. What we want to do is we want to have a start position and an end position to jump from. The start position will just be whatever we are now, so get actor location. And the end position is going to be where our target is. So get our attack target and get their actor location. But just like with the jump from the previous one, we want to add a bit of offset to the Z value. So I'm going to right click here, split this. The X is going to be the same, Y is going to be the same. The Z, we're going to add about 100 units to it, like 1 meter. Just to give ourselves some buffer. And then we use this output velocity to call launch character and click XY override and Z override. Right, now what this will do is it will just jump to where the actor's location is. I'm going to make it a bit of a smarter jump later on. So I don't want it to just jump where the actor is. I want it to jump where the actor will be after an X amount of seconds. Because if the target is running away from the enemy and the enemy jumps to where they are now, well, by the time they land, the player will be far gone. So if the enemy calculates where the player will be in, say, a second and jumps there, then it's a sort of a predictive and more smart behavior. But first, let me show you this jump to location first. So going over here in jump, we're just going to call jump to attack target, and we're going to pass the attack target. All right, let's see how this looks. So attack me. Let's actually, so right now the attack, he's moving too close. I'm going to edit this for now, but remind me to change it later on. So right now we move to the attack radius, right? So let's go to our melee enemy here, and in our get ideal range, let's have the attack radius something like 400, so that he attacks from a bit further away. All right, so now you'll see he's jumping to me, he's moving, and he lands where I am. Boom, attacks. Nice. See that again. I'm running away, jump. Very nice. And the entire capsule is moving. The blending is happening nicely. Now, before we calculate the future location, I want to fix something else, and I'm going to show you in slow motion what happens. Watch what happens when the enemy lands on the floor. Okay. Watch, and see he lands, and boom, you see that? There's slight delay between blending back from the jump animation to the montage there. So it looks very weird. And the reason this is happening is because as soon as the enemy lands, as soon as the jump is over and the enemy lands, they still have velocity. That means that velocity is not equal to 0, so we'll still be using the blend. But what we can do is tell the enemy as soon as you land, stop moving, so your velocity becomes 0, and we stop blending with the jump animation. And we can do that very easily over here in our jump to attack. There is an event dispatched when the character lands on the floor. We don't have to create that, it already comes by default with the character. So I'm going to pull off here and say assign landed delegate. This is what it's called, assign landed delegate. And we say on land or something. So when we land, first thing we want to do is, well, unbind So unbind event from landed delegate so that we don't do this when we're not jumping. And the event is this event. And after that, all we're going to do is get our character movement component and call stop movement immediate. Great, so this, as soon as the enemy lands, stop moving and unbind from the land delegate, so you don't do it again. Now let's see how this looks like, and again in slow motion, he's landing, and boom, he's blending perfectly now, or let's say not blending as soon as he lands. And the animation looks really cool. Great. So now I told you that if I'm running away from the enemy, there's no way that he's going to jump to my location, right? He's only calculating the location when the jump begins. So it's very difficult to hit me. So what we want is for the enemy to calculate where I will be or where their target will be in, let's say, a second, and jump to that location. Luckily, we can also do that quite easily. I'm going to create another function for it. So over here in our functions, I'm going to create a function called, right now I'm going to create it in the melee enemy, but we'll move it later on to a more, to a better place. I'm going to call it calculate future actor location. All right, so this this function is going to take two inputs. One is the actor that we are calculating their position, and the other is, I hate when this happens, and the other is time. So how long in the future do you want to calculate their position? It's going to be a float. So if this is 1 second, then calculate where they're going to be in 1 second. If it's 2 seconds, calculate where they're going to be in 2 seconds, and so on. And as an output, it's going to return a location, which is going to be a vector. All right, so how do you calculate future location? Very easy. So the location is the velocity of the actor multiplied by the time plus their current location. So what we need is first to get their velocity. So get velocity. And we're going to multiply this by the time. Oh, but actually before we do that, we want to ignore the z value because if the character is currently jumping and we calculate their position, then their position is going to be somewhere in the air. So we don't want that. So we're first going to multiply it by 1 on the x, 1 on the y, and 0 on the z. This ignores their upwards vector. And then multiply that by the time. And the time, let's default it to 1 second here. All right. And after that, what we want to do is get the actor's location and add to that this velocity times time. And that's pretty much it. So again, to recap in a comment here, the location is equal to velocity multiplied by time plus current location. And that's pretty much it. To also show this visually, what we can do, so back here in our event graph, let's first call it. Instead of getting the actor location as our end position, we are going to call our function that we just made. Let me move things a bit backwards here. We're going to call calculate future actor location, give it our attack target, and yeah, let's keep the time at 1 second. And I'm going to split this again because I still want to keep the x and the y the same. I still want to add 100 to the z. This offset is just, I found, makes things a bit more accurate. Okay, now to visualize this, like I told you, I'm going to add a node here called draw debug sphere and split this. It's going to be this x, well, this y, and this z. It's going to be a bit messy now, but this is just to show you how it's going to look like. plug this here, plug this here. All right. So now as I'm moving, the enemy will predict where I will be and jump to that location. So let me show you if I move towards him. He's predicting I'm going to be behind him. So he jumps there. You see that? That's pretty cool. Yeah, and now the jump is a lot more harder to get away from. But why aren't we drawing the debug sphere? We do this, we draw the debug sphere. Actually, something isn't right. Oh, the duration. I didn't put a duration. Let's say draw it for 2 seconds. All right. Yes, very nice. So you see even slight movements and he predicts that I'm going to be there and tries to jump there. Very nice. And again, if I show you this while I'm moving towards him, boom. Very nice. And do it again. Great. Now it's a lot harder. Perfect. And we can remove this draw debug sphere. All right. One thing we can also do is check first if the velocity is not equal 0, then just return the current actor location. There's no need to do all this calculation. Yeah, it's a small optimization. It's not really needed. But you can do that if you want. Great. Now, the second thing we want to do is, well, right now in our behavior tree, we're only doing one attack. We're doing this melee attack, right? And this is what we've been doing this whole time. We only call attack. What we want now is to set up sort of an ability system where the enemy can pick between different attacks based on which one is the right one at the current time. So we have a long range attack and we have a short range attack for now, right? And I think it makes sense that the short range attack you should do when you're closer to the target, and the long range attack you should do when you're further away from your target, right? So we want the behavior tree to be responsible for this decision making. So how do we get the behavior tree to do that? What I want is to add in our blackboard here the distance, the current distance from the attack target, to always have this value at hand to make decisions based off of it. So we're going to go to our blackboard. You can either open it from here or click on the blackboard tab. And we're going to add a new key, and we're going to call it distance to attack target. Oh, what am I doing? We're just going to be, sorry, a float first. So select float and then call it distance to attack target. Great. So this is a new Blackboard key that's going to be available for all of our behavior trees. But we want a way to update this value consistently. So we keep updating this value. What we did before, if you recall, we have this service. So a behavior tree service that runs every, 1 second and checks if our target is dead to stop attacking them. So we're going to create a new behavior tree service as well. So go over here to new service, say BTS service, put it in the services folder, and we're going to call it BTS underscore update distance to target. And just like the other BTS, what we're going to do is over functions override the receive tick AI. And this is going to be called on every tick, and we define how often a tick happens, and I'll show you how we do that. But first, let's calculate the distance. We want distance from our pawn to our attack target, so we need to know who the attack target is. That means go over to the variables, add a attack target key. We'll always communicate with Blackboard keys. It's going to be of type Blackboard key selector. Make sure to click the eye icon to make it instance editable. Then pull off of it and say get value as actor. So we're going to get our current actor location. So this is the enemy's actor location. And we're going to get the actor location of their target, which is our player. And we're going to get the distance between them. So we're just going to search for the distance vector node. which takes two locations and gives you, or takes two vectors and gives you the distance between them. And once we have this distance, we want to update our Blackboard's key, the new distance to attack target key we created with this value. So that means that this service should also know what this key is. So we're going to add a new variable, call it our distance to target key. Also click the eye icon. And then we are going to set that. So pull off of this and say set value as float. We know it's a float, so set value as float. And this is what we're going to do on each tick. Just set this value as a float here. Excellent. So then we want to use it in our behavior tree. So back to our behavior tree. We want to use it in our in this part. So let's create a new sequence node here. I can just put it on the whole combat state, but then it's also going to be called on is wielding sword, which is not really important. So I'm going to create a new sequence of actions here. And I'm going to call this one, I don't know, combat ready. So once you equip the sword, you are combat ready. And I'm going to put our new service on this combat ready. Update distance to target. The attack target key will be attack target. Our distance to target key will be distance to attack target. Now here is where we set how often this ticks. I want it to tick every 0.1 seconds with no random deviation. So every 0.1 seconds, just tick and update the distance. Great. So now that we do that, we always know what our distance is. So we can start doing conditions based on that here. So to do that, we can have a selector. So do a selector, and it's going to select between two attacks, whether I should do the jump attack or the short range attack. So assume that this is an attack and this is another attack. Right now they're both the same, but assume they are different ones. We want to add a condition for this one. So I'm going to right click on it and add a decorator called Blackboard. So Blackboard decorator is where you can check certain conditions on any Blackboard key. Which, by the way, we use for the states. So we check if the state Blackboard key is frozen, is investigating, blah, blah, blah. So we're going to use it as well here. So click on the Blackboard condition and say the Blackboard key is the distance to attack target. If this distance is greater than or equal to, I don't know, something like 400, then do the long range attack. Otherwise, do the short range attack. Obviously, right now, these are both the same attack, so we need a way to differentiate between them. I can create two separate tasks for short range and long range, but they have a lot in common. So let me show you. This attack, if you recall, it's the entire attack sequence. It tries to check if there's enough tokens to attack. If there are enough tokens, then it sets the movement speed to sprinting, clears the focus, moves to the attack radius, and then sets focus again, does the attack, and when the attack is finished, it finishes executing. So everything here is going to be common between the two attacks, except just this part. Which attack function do we call, and which distance do we go to before attacking? Obviously, for the short range one, you need to be pretty close to attack, and for the long range one, you need to be a bit further. So let's modify this existing task to allow it to use both attacks. So how we're going to do that? Instead of calling this the attack radius, let's actually call it the... actually, no, let's keep this attack radius. That's fine. And here is where we need to know which attack we can do, right? Now, you can't pass in an attack as a function, but what you can do is pass in the name of an attack to this task. Tell it to do this attack or that attack. But we don't have really names yet, so let's create that. So here in our enemies folder, I'm going to create a new folder. I'm going to call it melee enemy, and I'm going to put the melee enemy here. And next to him, I'm going to create a new enum. So search for enumeration. And this enum is going to be called melee attacks. So this is just a list of all the attacks the melee enemy can do. I'm going to add 3. The first one is just default. It's always nice to have default. The second one is short range attack. And the third one is long range attack. Great. And over here in our melee attacks, behavior tree task, I'm going to add a variable, call it the attack name. And it's going to be of type this enum we created, melee enemy attacks. Also click the eye icon. So over here, before we do the attack, I'm going to actually delete this attack. And I'm going to do a switch. So get this enum and do a switch on it. Oh, and by the way, right now we're casting to the base enemy. We actually have to cast to the melee enemy instead. So I'm going to also replace this with a cast to melee enemy. Where was our pawn? We cast the pawn. Alright, so we're casting our pawn to our melee enemy. We're binding at the end, and we're doing a switch. If the cast fails, just finish. If cast fails, finish execute with success false. Alright, so now that we have this switch, we want to know which attack to do. So for the default, just call the attack message from the blueprint interface. And give it the attack target. For the short range attack, we pull off of the melee enemy and call short range attack. And for the long range attack, we do the same, pull off of this enemy and call long range attack. And they both also need the attack target. All right. It's a bit messy, I don't want to waste your time cleaning up these nodes, but it's a good idea to make sure your lines are a bit clean. All right, and after that, we're going to add a reroute node, which is just this thing, combines a bunch of different outputs, and we're going to bind and finish execute when the attack is over. By the way, adding a reroute node here is the same as double-clicking on this. It's just a reroute node as well. All right, so... oh, target. Yeah, target is this. I forgot that guy. All right, so now that this behavior tree task is modified, let's see how we can use it. So for this is going to be our long range attack. We can rename the node here to long range attack. And this one, let's name it to short range attack. So for the long range attack, our attack radius, let's actually use our defend radius for that. So that means you can be in the defend radius before you actually attack. And the attack name is long range attack. Here, tokens needed 1, attack radius, and attack name is short range attack. All right. Now, one final thing is we need to revert our attack radius and defend radius, which in this case, this really means the radius of the short range attack and the long range attack. So let's make this one 200 and this one, yeah, 400 is fine. Great. So again, what we have now is if the distance to attack target ever exceeds 400, then do the long range attack. If it is not more than 400, do the short range attack, and then do the weight in all cases. I'm going to decrease this weight a bit. I think it's a bit too much. Anyway, let's see how this looks. All right, so now the enemy should jump at me, and he didn't jump. Oh, okay, so now he did, but in the first one, he didn't jump, even though I was very far. But he jumps the second time around. This probably means that this value, distance to target, isn't set the first time you enter the tree. And probably because as soon as we enter this combat state, we wait 0.1 seconds and then call the tick. So during these 0.1 seconds, this actually already happened, and this check happened and failed because distance to attack target is not set. So to fix it, there's actually something easy we can do, is check this box on the service. say call tick on search start. That means that as soon as you enter this branch, call the tick function and don't wait for the 0.1 seconds the first time. Okay, so this should work. Let's see. So he should jump now, and perfect. Okay. And if I'm close enough, oh, actually, why is he strafing? Okay, so he shouldn't be strafing at all because I don't have a cooldown. He should always, oh, this is a sequence. So he's always going to attack and then strafe. I'm mistaken. This should be a selector because we want to choose between attacking or if we're not, or if we can't attack for any reason, like there's a cooldown, which I removed now, then strafe. But right now I should always be attacking. So I'm going to replace this with a selector. Put my service on here, move these, and call this one the combat ready. Okay, so now we're selecting between either attacking and strafing, and since I don't have anything to prevent this node from failing, so nothing makes this fail, then we'll always attack. So now let's see, he should jump at me, he's far away, and now he's close, normal attack. Great, and if I move far away, let me try moving further. No, still doing the normal one. Oh, now he's doing the jump. I'm far away, and jump, yes. Let's test that again. Farther away, jump, closer, normal attack, and further away, jump, perfect. So one thing that you'll notice is that sometimes even though I'm moving far away, he's still doing the normal attack, like here. This is because right now he is in the short range sequence. If you recall, the short range sequence already has a move to attack radius. So right now he's trying to complete the short range sequence, and when he reaches me, he can complete it. But now he's not in any attack sequence yet. So if I go closer to him, I'm still within the 400 meters. He's going to do the jump attack and predict where I'm going to land and attack. Boom. Very nice. So you can keep playing around with these values, with the attack range, the attack radius, defend radius, try to find value that works for you. And also you can play around with the conditions. So right now the only condition I have is if the distance is greater than 400. Maybe for your game you want a cooldown for the long range attack. If it's not on cooldown, then always do it. Otherwise do the short range and so on. So there's a lot of things you can do, but for this video I showed you how, and yeah, you can make it your own. And that's it. As always, thank you all for watching. If you enjoyed this part, please consider giving a like and subscribe. And if you want to download the full project files, the animation, the code, and everything, you can get that free from my Patreon, a link down in the description, as well as right here. For the next part, I'm gonna continue adding more abilities to different enemies. So next part specifically, we're gonna add a really cool like spinning attack for the melee enemy where he spins his sword and follows you around. And then we're going to be adding some different ranged enemy attacks, mage enemy attacks, and so on. So this will allow us to create multiple different abilities or multiple different attacks, which we will then use all of them in the boss fight. Because boss fights are usually just a combination of mechanics that you've encountered in previous enemies, but combined together to become a much more difficult and challenging fight. So I'm working my way up to that to make something that's really as you see it in proper games, and not just like, oh, here's a boss, here's a couple of animations and a couple of attacks. No, but this will really be a progressive system and will teach you how to not only create smart enemies, but also teach the player the mechanics of certain enemies as they progress through your game. So I hope you enjoyed it, and I'll see you there.